Hello everybody. It is 1:30 in the morning and let's knock this out. We're going to do notes on simplifying radicals in exact form. This is the paper that you should have in front of you, so if you didn't print this, please do. And let's go and get to it. So I want to go over some terminology first. This thing inside the tail is going to be called an index. If there is no number written there, it's a 2. So there's a 2. But you'll see later on in classes that that index could change to a 3, 4, 5, whatever you want. And, oh gosh, oh, I probably should not put that camera on. But what can you do? So again, this number right here is called the index. If there is no number written there, the number is automatically 2. And that number could be anything from a 2 to whatever you really want. It's always a whole number. This part inside is called a radicand. Radicand. Alright, sweet name, awesome title. A radicand is just a thing that goes inside the radical. So I'll just type that out for you because my handwriting is atrocious. The radicand is the thing that goes inside the triangle. I said triangle, but again, it's 1:30, guys, and sometimes I don't think very well at 1:30 in the morning. You know what I'm thinking? I'm thinking sleep. Sleep sounds awesome. And then finally, we got this nice little squiggly thing here. This part is called the radical. It's just a name for the actual symbol, the mathematical operation. So it's just and if you've already done this, done problems like these, worked with radicals before, go ahead and raise your hand and show only yourself that you know this. No one else can see you, so I hope you didn't raise your hand. Did I use that joke alright? I feel like I might have used that joke alright. Okay, but that's your terminology here. So a radical is a name for a mathematical symbol. A radicand is that thing that goes inside the radical. That number that's inside the tail is called a index. Ooh, that's going to be a long, long sentence. Let's just reduce that size, turn it a different color, and let's move it and just make it look at a cool angle. Oh my gosh, look how cool that angle is. Okay. So now let's go and I want to go over a couple things here. Number one, I want to go over this part, square root of 81 and square root of 8. So if you were to use a calculator, nope, not what I want. Not all what I want. If you were to use a calculator, okay. I'm gonna bring up my calculator for you guys. I hope you guys are doing okay. Doing okay. Yeah. Doing it. Living it. Doing things that are new. On your notes, I hope while you're waiting for this calculator to load. On your notes, you should have this table. This table is going to come super, super handy. It's all the square numbers. So I just want to point out here that this is all the square numbers from 1 squared all the way up to 30 squared. Okay, so those are all your square numbers from 1 squared up to 30 squared. And we're going to need those for our test today. And then these two are the square roots, which is basically it takes these and reverses it. So the square root here is 4, now the square root of 4 is 2. Alright, and I would recommend keeping this paper on you at all times, even if you're going to a grocery store, so just bring that paper with you, because you never know when you could use it. Okay. Oh gosh, I'm sorry. It looks like the calculator is ready to roll, so let's go ahead and type in square root of 81 and see what the calculator gives us. Square root of 81 is enter 9. Alright, so square root of 81 is 9. Now, why is it 9? Well, there's a good reason. First of all, the index is a 2. Because the index is a 2, that means I'm looking for two numbers to get 81. So in other words, I'm looking for something times something equals 81. Okay, what are those two numbers? Well, let's see here. Let's go to this page again. Here it is. And I see 81 right here. Let's go 81, 81, 81, 81, 81, 81, 81, 81, 81. 81 is right here. The two numbers that multiply to 81 are 9 and 9. So because two numbers that multiply are 9 and 9, 9 and 9, then that means the square root of those, the square root of 99, or the square root of 81 is just 1 9. The answer is just 9. You can kind of do the same thing with the square root of 8. You could think of two numbers that get 8, but when you think about that, though, there are no actual two numbers that get you the square root of 8. Come on. It looks like it would have to be in between 4 and 9, but there is no actual number that gets me 8. No nice whole number. So let's see, it should be about 2 point something. Let's go and see what happens if I do the square root of 8 on here. Square root of 8 is, 2.82. Okay, 2.82, so let's just put that in here. This is approximately equal to 2.82. But what we're going to do today is we're going to be simplifying radicals in exact form. Which means basically, I'm going to rewrite this root in a simplified form just because I can. And my process for doing it is always going to be the same. In order to simplify radicals, so I'll type this out for you. In order to simplify radicals, look for the biggest perfect square that divides evenly into the radicand, into the numbers of the radical, which is called the radicand. Radicand was my nickname in high school. That's not true. I wish it was. That is so cool. Oh my god, awesome sauce. Okay, now let's go ahead and move this here. Let's go and move this. Let's go and make this a little bit more readable for our friends. I don't know about the rest of you guys. I don't even know the rest of you guys, but I miss my classes though. So hopefully, when I give you guys the opportunity to come check in, say hello, stop by, happy to help out, things of that nature. All right. So the way we'll simplify the square root is we're going to go to our little table here. And our little table was, by the way, if I went too fast, pause and rewind, man. Just pause and rewind. Let's just make sure this is working. Sorry, I had a little technical difficulty. So you're going to look for two numbers that get you 8. But one of those numbers you want to be a perfect square. The perfect square numbers are right here for you. So one of these numbers times another is going to get us 8. It actually looks like it's going to be this one, because 4 times 2 equals 8. So I'm going to just go back here, and this is going to be a preview of what we're doing this time. So what I'm going to do here, once my computer catches up to me, what I'm going to do, doop doop doop, come on, let's go, doop, 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 doop. Let's go computer, let's go computer, yeah, awesome. Okay, so what I'm going to do here is I'm going to rewrite this square root of 8 as a square root of 4 times 2. I know this part. I know what the square root of 4 is. Square root of 4, if I wasn't sure, I could just go back to 2 and square root of Just stick up. Okay, let's do it. So square root of 100 is the same thing as square root of 10 times 10. And because you need two numbers to get 100, the reason you need two numbers is our index is 2, so we're always looking for two numbers that multiply together to get 100. We got lucky. We got two numbers that are the same that multiply together to get 100, and those are tens. Long story short, numbers, that's what the index is. And those two numbers are 6 times 6, so the square root of 6 times 6 is 6. The square root of 8 we already did for you. That was at the beginning, so if you need to go back and rewatch that part, please do. And now let's go on to a number that we haven't seen before, number 4. So the square root is 72. So what I'm going to do is I'm going to That's not a whole number. And again, I only want, if you remember what I wrote, where that divides evenly into the number. Let's go just cross. Two. You're right, the square root of 72 is a square root of 6 times 2. Root of 36 is 6. And that other part, that root with the 2, has to stay here like this. And that's your answer, 6 root 2. So on this page, Alright, so those are your steps, and I hope those make sense. Not, you can just go ahead and raise your hand. Or, in all seriousness, because you can't really raise your hand here, right? Actually, we'll just stop the video and I'll do the rest in the next video.